This video poster presents a book about Australasian tektites. It contains 42 chapters, as well as a dictionary and a reference list. After watching each video poster, you can download relevant chapters for detailed readings, using the link in the description below. Australites, or Australian tektites, are regarded as being part of the Australasian strewn field. They have similar chemical composition and age, as tektites from Southeast Asia, but are very small. They have been divided into 9 different groups according to their form: buttons, lenses, round cores, ovals, oval cores, boats, canoes, dumbbells, and teardrops. On average, the Australites have rest masses around 1 to 2 grams, and they are ablated by atmospheric reentry, and show scleron, like splash-form tektites. Being that small, the parent tektites must also have been quite small. Both small and larger tektites could survive the atmospheric reentry, but larger Australites are not found, except for a few in a part of Western Australia. The modeled trajectory of tektite atmospheric reentry, by weight and reentry angle, over Australia, assuming dense atmosphere, starts at 80,000 meters altitude. Steep entry angles decelerates in a straight line, before falling vertically to the ground, while oblique angles decelerates at higher altitudes, before falling vertically. Heavier tektites with higher momentum takes longer to decelerate. Modeling the rest mass of Australian tektites, compared to 6,552 Australian tektites, fits well, assuming the start masses were between 5 and 10 grams, and reentry angles between 3, 5, and 7 degrees. Modeling a 1 kg tektite trajectory, based on start velocity and ejected start angle, shows the rest masses after atmospheric reentry, and shows which tektites would undershoot or overshoot Australia or exit to space. Some would disintegrate if atmospheric pressure exceeded the tektite's tensile strength, others would fully evaporate. Modeled ablation percent, depending on reentry angle, for 1 kg, 0.01 kg and 0.005 kg tektites. Low angles provide most ablation, and the higher mass of the tektite, the more is relatively ablated. See blue versus green bars. Larger tektites have higher momentum, and decelerates more slowly than small tektites, and thereby ablate relatively more at same reentry angle, however still retain larger rest masses, because of higher start masses. Example of a 76-gram tektite, re-entering the atmosphere, dependent on reentry angle and velocity. Between the blue and yellow lines, the tektite would disintegrate as the atmospheric pressure exceeds the tektite tensile strength. Below the blue line, ablation takes place, and above the yellow line, the tektite escapes to space. Download Chapter 23 from the link below, to read more about these topics and see the full impact video.